Hi everybody, this is John Roach with the Maryland Dam Safety Program, and I want to provide a quick tutorial on how to use the annual exceedance probability function of the Maryland PMP toolbox. This is a function that you'll use in your ARC Pro environment, and you'll have need to run the gridded PMP tool first. You can see I just finished that on the lower corner of the screen. It says the PMP tool was complete. So let's run the AEP tool. And you might ask, why is the AEP tool included in this PMP process? Well, AEP, or annual exceedance probability, we typically think of it as, let's say, the 100-year storm or the 1% AEP storm. Those are equivalent. If you're working in FEMA floodplain mapping, you might see the 0.2% chance storm or the 500-year storm. And if you're familiar with NOAA Atlas 14, that goes up to the 1,000-year storm event. But the PMP is often significantly rarer, so a significantly lower AEP than those common storms. The PMP is realistic, it's possible, but has low probability. Often. That probability, however, can change depending on where you are across the country or across the state of Maryland and the type of storm that controls. So we can use this AEP data for risk-informed decision making, particularly quantitative risk analysis, as we're assigning risks and uncertainty characteristics in a potential failure modes analysis or other similar efforts. So how do we do the AEP tool? Well, if you've already been in ARC environment and you've run the gridded PMP tool, it's relatively simple. I'm coming up here on my geoprocessing toolbox here, and I'm going to go back one level, find my Maryland PMP tool, and click the Maryland Basin AEP tool. That's going to bring up, and it's going to ask me basically for 4 elements of input. The first is your basin outline shapefile. So that would be your drainage area or watershed shapefile. The second is your AEP durations. That's going to be 6 and 24. Might as well run both. Your output folder. And then lastly, the PMP points feature class for each storm type. So how do we get going here? We're going to use the example of Centennial Lake in Howard County, Maryland. So let me browse to find my watershed information there. I've got a USGS stream stats output right here. So I'm going to grab that watershed shape and say, okay. For durations, I'm going to select 6 and 24 hours. Doesn't dramatically change the time that it takes the tool to run or anything. So why not? Output folder path. Okay, let's come back here and browse. We're going to go to Centennial. We'll create a new folder, let's say, and we'll call that AEP results. I'm actually going to take away that space because you can't have spaces. So it's a good reminder. We can do an underscore instead. And now lastly, these PMP points feature class. So what is that? You're going to grab that from your PMP tool output. So again, we'll browse. You'll see I have my PMP folder here. That's where I save my results from this most recent analysis. And then I've got my general, local, and tropical storms. So we'll just start in order. We'll click on general, and then we'll click on this geodatabase file. Double clicking, and now I've got my general PMP points file geodatabase. We'll add that. And then we'll keep on doing that. Let's see, we'll come back a couple levels, local storm, double click on the geodatabase, double click on the points file, and then lastly, our tropical storm. All right, there we have it. Now we're going to hit run. The tool takes a few moments to run. And what it will provide is an image file that shows you the annual exceedance probability and for each storm type. spare you the time of having to watch the tool run, I'm going to jump right to an output for a different dam that I've run recently. And I'm going to show you the 6-hour AEP plot. This is for the Liberty Reservoir. So you'll see here, this is a 6-hour storm. It's likely that the local storm controls for that 6-hour, given that its PMP depth is 19 inches. And it's 1.7 times 10 to the minus 8th exceedance probability. That's pretty rare. We have confidence bounds, you can see, on all of that. I'm going to slide over this CSV output as well. This provides some information and data for you. So what you'll be able to see is the exceedance probability, the 50% confidence interval, 5%, and 95% confidence intervals. So for this dam, if we were to look at, let's say, the 100-year storm, exceedance probability 1%, it's saying it's about 0.66 for a 6-hour, 0.66 inches for a 6-hour PMP. You may say, well, that seems significantly lower than a typical 100-year storm, but that is a distributed over the entire watershed depth. So for that 19 inches we had, it looks like it falls, approximately here, 1 times 10 to the minus 6 or 7, 8, sorry, 7 or 8, which is what the data showed. There you have it. Now you've got this information, and if you're going to be using it for risk analysis or other types of efforts, hope you enjoy, and stay tuned for more tutorials, tips, and tricks on using the Maryland PMP tool and other design challenges for dams in the state of Maryland.